I'm Anil Kumar, and here is a tips question on average rate of change. Water is draining out of a conical tank at a constant rate of 4 feet cubed per minute. Before the tank began draining, the water level was 12 feet and the diameter of water's surface was 8 feet wide. Calculate the average rate of change in height with respect to time as the water level decreased from 12 feet to 6 feet. The formula for volume is 1 by 3 pi r square h. Now to solve such questions, it's a good idea to sketch and then think about it. So let's first sketch a conical tank. So let me make a cross section here of a cone. So it's kind of like this. What we are given here is that initially the height is 12. So this height is 12 for us. And the diameter is 8. So the diameter is 8 for us. So half of it will be 4. So we can say the radius is 4, right? So that becomes the radius. We need to calculate average rate of change in height with respect to time as water level decreased from 12 to 6 feet. So let us say the height is 6 feet. Let's say this is the position. At that time, what is going to be the radius? So this is one more thing which we need to calculate when the height is 6. Well, this is easy calculation. We can use similar triangles. This will be perpendicular and the big triangle is similar to the smaller one. So by comparing the ratio of sides, we can get r, correct? So what we have here is that 4 over 12 is equals to r over 6. So that is 1/3, right? And so from here we can get r is equals to 6 divided by 3, right? That is the value of r. That is 2, right? So it is 2 feet. So when the height is 6 feet, at that time the radius is 2 feet. Now this helps us to calculate the volume for 12 feet and 6 feet, right? So let us first calculate the volume when height is equals to 12 feet. So at that time we know radius is equals to 4 feet, right? So we'll substitute these values and calculate the volume, which is 1 over 3 pi, r is 4, so 4 square, and height is 12 times 12. So that is the volume when height is 12 and radius is 4. Let us also calculate the volume when height is 6 and radius is 1/3 of that, which is 2. So we get 1 by 3 pi, r is 2 square times 6, right? So that becomes the volume. So these are the two volumes. Now the question is, calculate average rate of change in height with respect to time. Well, that is rate of change of volume. Now we need to find rate of change with respect to time. What we are also given here is water is draining out of conical tank at a constant rate of 4 feet cubed per minute. That means rate of change of volume with time is 4 feet cubed per minute, right? So what we know is rate of change of volume over time is actually equals to 4, right? Feet cubed per minute. That is given to us. Now from here we can find change in volume, that is delta V. Once we find change in volume, we can find change in time by dividing change in volume by 4. So now we know change in time, delta T. Change in height, we already know it is from 12 to 6, right? So the change in height for us is, change in height is equal to 12 minus 6, right? So it is 6. So what we will do is calculate our volumes and then divide that by 4 to get change in time. And once we do change in height over change in time, we'll get our answer. So that is a strategy. Let's calculate. So we'll use calculator to calculate the volume when height is 12. So it is pi times 4 square, let me write times 16 times 12, and we'll divide this by 3 201.06. So we get 201.06, and for the other one we have volume equals to pi times 4 times 6 divided by 3, and that is 25.1327. And to find change in volume, we can say 4 is equals to, change in volume is difference of these two, right? So let's calculate delta V, which is 201.06 minus 25.1327, right? That is change in volume, right? So from this change in volume, we can find change in time by dividing by 4, correct? So let's find this difference. So minus 201.06, that gives us 175. So this change in volume is actually equals to, so let me write here delta V equals to 175.92, right? So if you know this change in volume, that is delta V, we can find delta T. Change in time will be, we'll divide this by 4, correct? So we'll have 175.92 divided by 4. That gives us change in time. So we'll divide this by 4. We get an answer of 43.98. So let's say approximately 44. So change in time for us is 44. So what we really need to find is, let me just do it like this here. Okay, average rate of change in height with respect to time. That means we want to find delta H over delta T, correct? Change in height is, let me write down in a different ink now. Change in height is 6 and change in time is 44. So that is the answer. So we'll do 6 divided by 44. 0.136. Correct? So that is the answer. The units will be height changes in feet, right? And time is in minutes. So that becomes the answer for this question, right? So that is how we need to solve. So we get our answer, which is equals to 0.136 feet per minute, right? So we'll just complete this, right? Delta T, and then we've calculated delta T by cross multiplying, which we did here, right? Kind of like this. Okay, so let's review what we did here to get to the answer. First step is, in any word problem, sketch and figure out what you have, what you need to find. Since we knew for 12 height the radius is 4, we found for 6 it will be 2, 1/3 of the height. That is how they are related. So we found the radius. Knowing radius and height, we could find volume in two cases, when the height was 12 and when the height was 6. Difference in volume told us how much water was drained, and knowing the constant rate at which water is draining out, we found the time. So ratio of change in height over change in time gave us the average rate of change in height with respect to time. That is how we need to solve this. I hope you appreciate it. I'm Anil Kumar. You can subscribe to my videos and look into more examples like this. Thank you and all the best.